On Earth, we think of places like the Sahara Desert, Antarctica, or the bottom of the ocean as extreme environments. But they're nothing compared to some of the places we've explored out there. We've sent probes onto a planet hot enough to melt lead, landed beside frozen methane rivers, dropped a spacecraft into a gas giant, and even gone beyond the planets themselves to explore the void of interstellar space. And that got me thinking, what happened to them? What are they like today, years after their missions were completed? Well, let's start with the time we visited a planet that melts machines.
In 1982, a pair of robotic pioneers embarked on a journey to one of the most hostile environments in our solar system, the surface of Venus. The Soviet Union's Venera 13 and 14 probes were engineered to withstand conditions that could melt lead. These 2.7-meter tall probes were built for one purpose: to survive for as long as possible where nothing else could. An atmospheric pressure 92 times that of Earth, the equivalent of being nearly a kilometre underwater. Temperatures exceeding 460 degrees Celsius, far hotter than your oven's highest settings. And a suffocating atmosphere of carbon dioxide. Venera 13 landed first, touching down on March 1st, 1982. Followed by Venera 14 just 4 days later. Incredibly, we can see the probes and their surroundings from the images they captured just moments after they had landed. These were the first and only colour photographs ever taken from the surface of Venus. We can even listen to their surroundings because they also recorded the sound of this hellish environment. A faint, haunting rush of wind sweeping across Venus's surface. However, as incredible as their surroundings are to view and to listen to, the harsh conditions would have soon begun to take hold, gnawing at the probe's exposed surfaces. The immense pressure, 92 times that of Earth's, would have been pressing relentlessly, like a small car pushing down on every centimetre of their bodies. For a brief moment though, the probes endured, lasting far longer than had been expected. Venera 13 transmitted its final signal after 127 minutes, and Venera 14, weakened by the same conditions, lasted just under an hour. Yet, what became of these robotic explorers after we lost contact? Venus would have continued to attack the probes. The external heat would have been so intense that once the cooling systems failed, the temperature inside the vessels would have skyrocketed. Any polymer materials used for wiring, seals or gaskets perhaps would have charred and vaporized. Within just a few hours of losing contact, the external atmosphere probably entered the vessels. Sulfur dioxide and other acidic gases would have rushed inside, corroding and oxidizing the internal metal components, killing off the probes for good. Over the coming weeks, months and years, the titanium and steel framework may have softened. Corrosive sulfur compounds would have eventually crept into every crevice, eating away at once pristine surfaces, forming a patchwork of darkened scars. Today, more than 4 decades later, what remains of Venera 13 and 14 is of course a mystery. The surface of Venus is shrouded by a thick blanket of gas, meaning we cannot see the region where they exist. However, they are certainly just silent sentinels on a lifeless plain. Their smooth, metallic sheen long since vanished, probably encased in layers of oxidation and dust. Their structures may have even partially fused with the volcanic terrain surrounding them that we saw in the images they sent back. The noble metals like gold and platinum would still remain, possibly even visible in patches. gleaming faintly amidst the matte and scorched remnants of less durable materials. Now the probes likely resemble ancient corroded artifacts, darkened by chemical reactions and etched into Venus's hostile landscape, perhaps even adorned with yellow deposits of sulfur. However, although they are no longer whole, their story remains. The Venera 13 and 14 probes have never been talked about more. Sure, they are certainly weathered and worn today, but they do endure on a world where no life survives, but where they represent an incredible example of human curiosity elsewhere.
And somehow, that isn't even the strangest environment we've explored, because much further from the Sun, we landed on a world where rivers flow, but water behaves like rock.
The wind howls as the sprawling landscape below inches ever closer. You could be forgiven for mistaking this scene for the jagged coastlines of Canada or Scotland, yet we are 1 billion miles from those countries. The Huygens lander has just entered the atmosphere of Titan, Saturn's largest moon. When Huygens touched down on Titan on the 14th of January 2005, it entered the record books as the most distant landing we'd ever pulled off. To this day, it remains the only time we've ever landed in the outer solar system. Titan blurs the line between moon and planet. It's one of only 2 moons in the solar system larger than Mercury, the smallest planet. It is also the only one of nearly 300 moons in the solar system to have a thick atmosphere. Atmospheric pressure on Titan is 1.5 times that of Earth's. The only thing that stops it from being a planet is that it happens to orbit Saturn instead of the Sun. These tantalizing features make Titan arguably the most Earth-like place in the solar system, but with one key difference: temperature. It's typically minus 180 degrees Celsius on Titan. Such frigid temperatures mean that water ice stands in for rock, and liquid methane takes the place of liquid water. Yet, as we've seen, the resulting landscape is eerily familiar. The probe was about 2.7 meters and weighed roughly 318 kilograms. In all, the descent took 2.5 hours. Safe and sound on the surface, the probe could now survey its new surroundings. It quickly took a now iconic photograph, an eerie panorama of a distant world equal parts alien and recognizable. There is evidence that the icy pebbles have been smoothed, perhaps by a flowing liquid. In other words, Huygens found itself in a dried up riverbed. All of Huygens' data had to be gathered in a hurry. It only ever had 3 hours of battery life, and Titan is so dim that solar power was out of the question. Initially, mission controllers expected that most of the probe's power would be consumed during the landing phase. Before touchdown, they had planned for just half an hour of ground-based observations. In the end, Huygens eked out an admirable 72 minutes. It is hard to say with any certainty what state Huygens is in today, 2 decades later. There's a chance it could be buried in silt, or that it was washed away in a flash flood. Despite the harsh conditions of Titan, Huygens today is still probably intact. Its sturdy, highly resistant aluminium structure is likely still whole. However, its internal components, electronics, insulation, and parachutes would have almost certainly begun to deteriorate, possibly becoming stiff and brittle as the freezing temperatures gnaw at it. Today, the probe is a frozen, weathered relic, slowly becoming a part of its surrounding landscape. Over decades or centuries, if it hasn't already, Huygens will likely be encased in hydrocarbon sludge, partially preserved but trapped on Titan forever.
But not every probe gets to remain as a relic. Some worlds do not preserve our machines. Some consume them entirely.
In the vastness of the solar system, the gas giant Jupiter looms like a titan. Colossal, chaotic, yet endlessly captivating. This massive planet has been visited so far by 9 spacecraft, revealing a world of titanic storms and magnetic fury. And although the orbiting Galileo spacecraft came to a fiery end when it was deliberately sent plunging into Jupiter at the end of its mission in 2003, only once have we sent a probe into the gas giant, attempting to find out what lies below the clouds. In 1995, a small bullet-shaped probe, simply named the Galileo Atmospheric Probe, dove into Jupiter. It was the first and so far only time we physically explored the inside of a gas giant planet, studying Jupiter's cloud layers as it swallowed our machine whole. The Galileo Atmospheric Probe was no ordinary machine. It was small, just over a meter across, but it was a masterpiece of engineering. Built for one task and one task only, to survive as long as possible where no machine has ever explored before. It entered the Jovian atmosphere in December 1995 at an incredible speed of over 170,000 kilometers per hour. Fast enough to jet from Los Angeles to New York in just 90 seconds. It endured extreme heat as it slammed into Jupiter, as friction ignited the air ahead of it. The heat shield began to vaporize, losing around 60% of its mass as it carried away the inferno in front of it. The incandescent shockwave ahead of the probe was as bright as the sun, reaching searing temperatures above 15,000 degrees Celsius. Then, an explosion, the sound of a mortar as the drogue parachute deployed. Explosive bolts were fired, releasing a cover which in turn pulled out the main parachute. This entire process was designed to take less than a few seconds. With the billowing fabric above slowing it down, at maximum deceleration, the probe endured a force of 228 Gs. Now the probe was ready. Its sensors are activated, and it began to transmit information about its new, bizarre environment. For 61 breathless minutes, the probe's transmitter returned valuable data. Its instruments revealed a world far stranger than scientists imagined. Data indicated an intense radiation belt about 50,000 kilometers above Jupiter's clouds. Few organic compounds were found, and howling winds blew at speeds of about 640 meters per second. The entry probe also found less lightning, less water vapor, and half the helium that had been expected in the upper atmosphere. Each reading defied expectations. Each byte of data rewrote what scientists thought they knew about Jupiter. Then, silence. The probe's transmitter failed. The question of what happened next is easy to answer. The Galileo Atmospheric Probe fell deeper and deeper until eventually it was crushed, vaporized, and then lost forever. No explosion, no wreckage. It became a part of Jupiter's atmosphere. It completed its mission. It had successfully done in around an hour what nothing had ever done before it. No other probe has ever followed.
Some machines were left on the surfaces, some became part of atmospheres, but 2 others escaped all worlds entirely. They are not trapped on a planet or a moon. They are trapped in the space between stars.
They were never meant to last this long. Built in the 1970s, launched with a mission to explore the outer planets, and powered by a technology that's now ancient by today's standards, Voyager 1 and Voyager 2 are the furthest travelled objects ever made by human hands. Today they drift alone, billions of kilometres from home, trapped in a realm no spacecraft has ever explored before, interstellar space. A place where the sun is just another distant star. In 2012, Voyager 1 became the first spacecraft to officially cross into interstellar space. Voyager 2 followed in 2018. They had broken free of the sun's protective bubble, the heliosphere, and entered the raw interstellar medium, a realm of faint gas, magnetic fields, and cosmic radiation. The temperatures here hover just above absolute zero. Particles are scarce, but fast and deadly. And yet, these 2 probes keep moving forward, slowly and silently. Their plutonium power, their life source, is fading, however, now providing only a trickle of energy, just enough to keep a few scientific instruments working. Systems have been shut down, heaters disabled, instruments turned off one by those still managing their power supplies all the way from Earth. Yet, all these years later, a trickle of data still remains. In some time in the early 2030s, it is expected that the last power cells will fade. No more data, no more updates, just silence. They will go dark forever. And yet, they will keep on moving, but nowhere fast. Not until around 30,000 years from now will the Voyagers pass through the Oort cloud, the shell of comets, and icy rubble that orbits the Sun, finally waving goodbye to its solar system of origin. At that point, for the first time, the probes will begin to feel the gravitational pull of other stars more strongly than that of our own Sun. By around 250 million years from now, the solar system and the Voyagers alike will complete a full orbit around the Milky Way galaxy. At this stage, if they have managed to avoid any collisions, each probe would likely look extremely battered. Interstellar space is far from an empty void. Dust would have been crashing into the Voyagers at a speed of a few kilometers per second. These grains would act as a steady rain that slowly chips away at the metal skin of the spacecraft. A dust grain only 1/1000th of a millimeter across will still leave a small vaporized crater when it impacts. And over millions of years, this might slowly eat away at the probes. Gravitational influences from enormous clouds of gas, other stars or cosmic bodies might tug at the Voyager's trajectories as well, bending their paths into new orbits and new environments. But despite the onslaught of interstellar materials and potential detours, both probes, although weathered and potentially battered, are likely to survive, at least partially intact, for a span of over 5 billion years, some scientists have predicted. Depending on their luck, who knows, the Voyagers may be able to ride out trillions of years, long enough to cruise through a truly alien cosmos, trapped in a universe that to us would be completely unrecognizable. And yet, even after all this time, there is a chance that a trace of humanity may still exist. The golden record, etched in copper and plated in gold, shielded behind its aluminium casing, might outlive every other part of the spacecraft. If someday, in some distant star system, someone finds it, they may still be able to decode the sounds of Earth and hear our ancient voice echoing through the cosmos. And in that moment, they will know we once existed. We dreamed, we built, we reached.
When you look at all of these missions together, it's honestly incredible what humanity has achieved up there. We've touched boiling worlds, frozen worlds, worlds with no surface at all. And we have machines drifting between the stars themselves. Some survived minutes, some lasted decades, but all of them became part of the environments they explored. Tiny pieces of Earth scattered across impossible places.
That isn't me, that's AI. And the reason I'm showing you that is because content like this is becoming increasingly common, especially in space and astronomy. But V101 SPACE is built differently. This channel is researched, written and narrated by me, a real human who actually checks sources and cares about the stories behind each video. That's why I created the V101 Alliance, a membership offer that for less than the price of a coffee each month allows people who values this kind of content the chance to support it directly, and in return get meaningful perks. So if you'd like to join this mission and become a part of the V101 Alliance, become a member today for just $2 by clicking the join button that's located next to the subscribe button. I'd love to welcome you, and hopefully I'll be seeing your name in one of my future videos very soon.